Hello, everybody. Vlad and Ula and the whole workshop team. Thanks you for having me. It's an amazing lineup. Really humbling experience to be here. So today I'm not going to talk about actually getting your benchmark state-of-the-art battle, adding 1% more. Actually, I will tell you about how to make an impact with it and make some decisions on production. I'm Łukasz Dziekan. I'm CTO of FinAI, one of the founders, and I will tell you what we did. I will talk you what is actually the problem. Like we have a sense that there's a lot of noise in machine learning community about how to advance the machine learning, how to make the benchmarks better, the models more accurate, solve problems with such a little bit increasing accuracy, but we talk really little how to make real decisions that affect money. And when money is in game, it changes a little bit because people like stability, predictability, and actually even if they don't know how it works, they want to trust it, and that's why running it on production requires some serious reconsiderations apart running a Jupyter network and notebook and just thinking it's cool. I'll tell you how did we solve it in FinAI, and we are actually dealing in finance. We are a financial intermediary that issue loans, credits, up to 12,000 euro. So in other ways, we're running a lottery when if you crack it, you win $12,000 or euros and actually get away with it. And some key takeaway points. So my team, we had like 6 people in machine learning team. They were really confident about Jupyter notebooks, Python, their skills in like putting models together, training them. But then one day came and they had to put it on production where they actually didn't have impact or like manual tweaking, and the decisions would be made without their influence at all. They would just have to trust what they did, and it was really scary for them, and it was scary for me. And turns out that the road from your notebook to actually some code somewhere, as Emily told, it's not such a short way. And so we had to solve a lot of things. And surprisingly, in the last 3 years, when we started the FinAI journey, there was so little literature about it. Actually, the only biggest companies like Uber, Facebook, Airbnb were beginning to talk about that. And most of the papers were like, hey, how to increase your accuracy by 1% by adding 100,000 parameters to your deep neural network. Whereas they don't even tell how stable it is on different training data sets. So I'll tell you a little bit about data collection and storage, some model development techniques to increase stability, and how to actually deploy model on productions in 5 minutes rather than 5 days, and what we do about model management, sorry. Oh, yeah. So the problems we had 2 years ago. It took almost a week to get a model from Jupyter network to prod. We had performance issues, so sometimes the request would take like milliseconds, sometimes it would take like 1.5 seconds, and nobody knew why. Obviously, guys didn't write unit tests or integration tests, so when a weird input came in, it all crashed, and it just crashed. User got an error message, not cool. It was really hard to trace what kind of model we have on prod and what was the actual code that the data scientists run, and what actually was the sample it was trained on. And I ask sometimes questions like, okay, how are we doing last 2 weeks compared to the training data set? And I was like, oh shit, we don't know. So especially when you're running in finance, when you can possibly lose millions of euros in a week, it's not a cool question to have a such answer like that. So what do we do? This is my co-founder. One of the problems we have to solve is actually approve a loan application fully online. So no phone calls, we don't know the dude. We have to verify that he is he or she is she, and meet a shit ton of regulations in banking to make matters worse. So we take a photo of his ID, front, back, and a selfie. We actually take a video to figure out whether he or she lives, which is quite important, and detect a couple of stuff like whether or not this is a, for example, artificial video or altered video, or whether or not this is a photo of a photo rather than a photo of an actual object. So it's all pretty tricky. And when you think about GDPR, you probably know that there is no data set for pictures of IDs, right? It's really hard. Unless you maybe have one, then I gladly take it. Even with faces, it's not that easy. You could get some faces. Microsoft has a huge data set of celebrity photos, but it doesn't solve the problem, really, because you would be surprised what kind of selfies people take when they're actually doing it their own selfie. It's not a perfect photo, far from it. So this is the whole system, right? And where are the machine learning? It's just a small part, down on the right. And there's a couple of microservices that just serve machine learning. And it's, it's all monolith 3, it's all event sourcing. So my machine learning guys never worked with such an architecture. So they had to learn it, and we had to create some code of conduct, how to deploy a model to production in order not to break the whole system. This is actually the last iteration. It took us maybe like 3 failed ones. How do we communicate between the system and the model kind of engineering? So we have what is called business event listener, which pumps all the data to our machine learning environment. We use Azure, but imagine this is Kafka, doesn't matter. It's just a message passing infrastructure. And we have a router that just, routes all the events towards different machine learning models in order to, for example, monitor their performance or evaluate whether or not the input was right or bad. And it has to be scalable because, when we started, it was only like, hundreds maybe of photos a day. But when we offer it to a bank, they always ask, can it process 100,000 photos an hour? And we're like, we don't know yet. But then we prove it to them on some test data, and it works. The key thing is you have to make it as robust as possible. It cannot be like you don't know if it's error or not. So that's why there's a lot of these failed blobs that you make a request, a HTTP request, you have to handle, timeouts, network errors. When you run it on cloud, always something is wrong. It's just a matter of time, a service can go down, a whole region can go down. Obviously, it's rare, but it can. So you have to be really, really prepared to handle a shitstorm, and it has to be in every layer of your system. Even if the machine learning was just one part back in the whole backend thing. So one might say, as Boromir said, one does simply not build a distributed system. This is a famous quote from, 2 Towers. Biometric data is, wrong. You just can't let it fly on a, machine learning guy laptop. Probably you wouldn't like, if you use FinAI, that your face or your ID is flying on, Adam's laptop, because you'd say, they are so insecure, they are so reckless. So yeah, we don't. We had to completely isolate the data, so it's limited risk of leakage, because one photo leaks and I'm really done, probably. So we had to really isolate the whole data and make it really hard to process. But you're machine learning guys, right? You love to run it, your Jupyter networks on notebooks on your laptop. It's so hard when you have to plug in via some jump station. So I had to, make it a little bit easier for my guys. So we built a domain model for modeling. You had to build some tables in SQL, essentially speaking. So it's actually very little talked about, but when you train a model, there's an abstraction layer on it. You can tell you have observations, right? Regarding if you're making a classification model, a regression model, whatever, you have observations with label, with some value. Then you create sample out of observations, essentially a group of samples, of observations. And if Adam builds a sample, then it can be reused by Michał. Then you make a prediction, so you save it as a score. It can be thought as another observation of a model, but it can be easily compared between different models. And then model itself is an entity. It has metadata. It should answer the question, who created it, when, why, on what sample, and what did it predict? And we built this whole thing in 3 iterations. The second iteration was like that. My guys came to me and like, hey, we finished, it's awesome. It makes our model management so easy. And I said, did you use it? And I say, no. But we designed the whole ORM package. And use it and come back to me. And they say, yeah, maybe 35 tables is a little much. And they spend like 2 weeks migrating to like 9 tables, out of which 6 is here, and say, oh, that's much more readable. And now they have a package using Alchemy in Python. And then when they create a model, it just saved as a model ID. It was built on this sample, on these observations. It predicted those scores. The model has this form, this coefficients. It's saved in this location. And it's all clean. No more mess. Amazing, like highly recommend. So what about training? You have data solved out. You finally ask your machine learning, where did you build this on? And say, oh yeah, it's model ID 975, sample ID 355, done. You say, oh shit, that's cool. It's like reproducible now. But now training, can you reproduce the training actually? So we're solving a couple of weird problems. Obviously, you need to assess image quality. Not all photos are created equal. Some of them too dark, some of them too light, some of them have reflexes and makes important to OCR. And then this is my printed photo, and turns out when I wiggle it in front of a camera, it doesn't mean I'm alive actually. So you have to solve for those, so it doesn't crack your system. Turns out people don't move their head as much as Adam does. And then they take pictures of pictures, which you have to figure out those weird different artifacts on the photo. So a lot of work, even though it's a simple task. Like, does this person holding this ID have the same face at the same time? But it takes all those to actually reliably solve it. As I said, my guys don't have access to the production data. So we built a separate virtual machine that's completely on production environment only. It's not on UAT, it's not on dev, where they have access to production data. It can also have access to non-production data, which is, let's just say, external data, this Microsoft source, for example, for faces. And they cannot use internet there. So we had to build a system to download packages from Python, from other DevOps environment, in order to get any kind of usefulness out of it. And they obviously developed their Jupyter notebooks on their machines, but then they put it on this machine and to see whether or not it runs on the actual sample that they've devised it on. Obviously, storage is also encrypted and everything. And therefore, with this, when we run the same model twice with the same dependencies, the same data, it should give the same results always, period. If it doesn't, something's really broken. So it works on dev, right? And then it's an ops problem, as we all know it. The funny thing is we have no ops because we are like 25, 30 people startup. So they have to figure out who's the ops now. Obviously, working with untitled files is really hard, especially that this is so true that untitled 25 is clearly better than the previous one. And even in the famous guys, YouTube videos, it's very encouraged to use such patterns like that. So we decided that to have a different framework for that, to have actually some naming conventions. So we still use Jupyter, but each Jupyter network has to have a name with a certain convention. It has to have the load sample and tell what's the ID of the sample. The sample has to be prepared previously, therefore it enables you to have little ambiguity on that. We have all models logged in our DB. It's not a huge DB. That answers the questions who, when, what, how. How means what kind of model, and where means what kind of sample it was used to train it. That therefore makes it fully auditable. No questions are being asked about what kind of model is run where. And even if a different model on UAT or Champion Challenger, we already know what kind of models are there. The model is essentially a pipeline, sklearn. For most of them, some of them TensorFlow estimators that essentially are, the regular pipelines. Load some data, compute features, feature engineering pipelines, evaluate the model, assemble the learners if it's a blended one, optimize the hyperparameters and stuff like that. And all of those parameters that are used here are saved to the DB, so we know what's the final one. We do code review. It's not core review, it's code. So every of those notebooks have to be code reviewed before going to production by 2 people. And then we figure out different fuck-ups that happen, no exception handling, and stuff like that. If we are satisfied with the model, then we save it, and it's done. It's just this one function. Obviously, it does a bunch of ORM inserts in it or updates, but it's done. That's all it, the data scientist doesn't have to think about it anymore. We always compare the model before going to production with a formal decision-making. The decision-making has to answer a very simple question. Is it better than the current one? Under what circumstances it's better? And we always compare it to the one that's running or the other challengers that are running on production on the holdout sample. No questions asked. If it's not, then it goes down. If it is on certain metrics, then it goes up. And takes out, judgment out of it. And because we have the whole log, we know what to expect from this model on production. So let's just say we think 97% of the decisions of face match, so taking the photo of your ID and your selfie, should be automated. And if it's 93% because it falls below threshold, we say, oh, that's probably not as cool as we expected it to be. But maybe the current models were running on 91%, which is still better. So with this, it's just super easy. So we created the model, we saved it, we have all the metadata required to run it. Deployment. So this is when I was scared because we found a flaw in the model. It confused a man and a woman normal person would never do on test. I was scared shitless. And I asked how many minutes it takes us to replace the model or change its parameters so it is more sensitive to send the decisions to manual review. And it turned out to be 2 days. Way, way, way too long. So we decided to build a whole DevOps pipeline. So the model is a Flask app. Remember to use Junicorn because Flask is really slow, the dev system. It's published as a container. It puts in the Kubernetes cluster. It uses first canary release and then uses the swap slot. So there's zero downtime deployment. Obviously, you have to always avoid using, Docker latest. This will kill you. you don't know what version you will run on production because it's not tagged. So you have to have idea of a build, a tag, and always avoid any kind of ambiguities. You always have to know what you run on production. Each microservice, it's not just a model, as Emily said. It has to be monitored. So it has to have a contract to say, okay, I'm publishing this kind of event about evaluation, prediction, whatever, to feature store, so you can actually monitor real time and then reuse it for performance evaluation when you will eventually change it, because you will change it. Some models you will change in maybe a month, some of them will change in a half a year, but you will change it because you like change. It has to have health check. It has to have, tell you if it's running low on resources. Maybe it's, its RAM is, consumption is going through the roof. So you have to have health check. If it doesn't have health check, it's probably going to crash and you will not even know about it. It's also a good thing to, monitor it from typical engineering perspective, like what's the average response time? What's the median one? What's the 99th percentile? How much different they are? How's the RAM fluctuating? So treat it as a same actor as any other code in your system. The package, we have FinAI package. So we packaged all the logger, data contracts, image transformers, feature generators in a package. So there is no problem in like writing custom code. And this is wholly versioned. It has unit tests. So if a guy breaks a transformer or optimizes it and breaks certain functionality, he is having, tests show it. So if you write your code that's production ready, treat it as a code that software engineers will write. Unit test, integration tests are a must, and it has to be in your pipeline. It's no different than anything else you're writing, the guys who are writing, part of the front-end system or back-end. Because we have this package, now we have two packages, we write it into requirements. So to say which Docker uses what package version, therefore we always know what did we use in production to run certain model. And because we have the repository tag and image tag, we always know where it came from. TensorFlow serving I'm going to skip, but usually just use TensorFlow serving for serving TensorFlow models. It has pretty good management console, and it's very performant. So you've done it on prod. Now you have to answer yourself a few questions, right? Do you observe it? How long does it take you to observe? How does it work? Do you know if it failed? If you think it never failed, you're wrong. How do you know if the model made a wrong prediction? Do you have a feedback loop? Do you have a, let's just say, manual intervention process if you know it's failing? How do you measure scaling of such model? Can you run those microservices as stateless models, so you have 3, 5, 9 instances of it? Or do you actually use some state somewhere? How sure is your model when it makes a prediction? I'll give you an example. One day, we've noticed certain fluctuations in score distributions in FinAI, and we discovered that some people of Asian descent started to come into our platform. And if we didn't have monitoring, we would never know. And actually, obviously, models were calibrated towards more wide-oriented population, whereas we figured that it's not always the case. And they were actually making wrong predictions. How do you know whether a model receives a data input if it's anything similar to what you have trained it on? So we build a monitoring. We use Power BI, but your mileage may vary. You can use Grafana, you can use Tableau, whatever you want. So all the data from all the predictions are stored in this model repository that we've showed you before. That shows you this model ID made this prediction on this sample, even though on this observation, even though the observation is from production. So we have custom queries, we have ready-made queries, and we have alerts if something weird changes, if there's a change in thresholds. So essentially speaking, we monitor machine learning system as any actor within the microservice environment. Like Emily said, like they made aluminum, right? They monitor those electrical cells. Your model is a cell. It has sensors. Its sensors is, for example, what's the distribution of the scores it produces? What are the distributions of features that's being input into the model? You have the sensors, and you have to monitor them the same way. So you know, once a week we look at it at least, and we check for the any discrepancies, changes in trailing averages to see if there is a change observed. If it's classification model, you can monitor Gini or AUC or any kind of separation distribution measurement. We measure obviously the quartile 1, quartile 2, quartile 3 of the scores distribution to see if there are any outliers. We use the various metrics like average, median, standard deviation, shape descriptors. And this is just the queries that alert us if something sudden changed, or did it change over a week, change over a month, just to see whether or not something that we don't know is happening. Because it's really scary when you put it on production and you cannot observe it all. And if you're making important decisions, and in this case, this is a decision about 12,000 euro, you have to be trusting it. If you don't trust it, the executives will not trust it as either. So to end it, remember that data is your resource, but it's also a dependency of your model. It's not only a resource, it is actually dependency. So the sample you build it on is actually what your model depends on. Machine learning, in my opinion, is an engineering process. It has very little differences from software engineering process. Obviously, we have to tailor certain practices towards it, but it's really it, especially if it has to be run on production. Maybe we don't write all the ifs and fors and whiles, but we make code generated. So it's just let's just say a shorthand for writing all the ifs and wheres. But in the end, it has to be put in production and evaluate in a deterministic way. You should have your own infrastructure for training, and it has to be reproducible. If it's science, it has to be reproducible results. Therefore, always put in the same samples, same code, it has to give the same results. I highly recommend you to create this domain model as I've pictured on some slide. So you always know what model, by whom, when, with what data, and what is the expected performance, and what is the expected, the parameters of such models. And please do have some conventions. I know there's little literature about it, but just work with your software engineers to have conventions for naming, prefixes, postfixes, and then that solves it very easily, and it's also easy to validate. So why is it so little literature about it? I didn't tell you anything that's state of the art. It's actually state of the art to have CI/CD in software engineering, and it costs. It's so much cheaper to have the Jupyter network Untitled 24 and then put it on prod, right? And now I told you to build all this big infra monitoring and stuff. It costs you. But if you're serious about running machine learning on production, making a $10 million impact, you have to make costs. Otherwise, it will not fly. So please do use automation. Doing it once is enough. We are bored. We don't want to make the same thing twice. We're machine learning guys. The abbreviations are Polish, so I'll explain it later if you want. But essentially speaking, what did we achieve? Recalibration of the model, we don't use it automatically, but it takes 3-4 hours. I mean, it's done automatically, but the comparison of results takes 3 to 4 hours review. New model, 1 day. Monitoring is done online. It doesn't take 1 or 2 days anymore. I know now what I run on production. That's really priceless for your, for your heart. And debugging and diagnosis what went wrong, it takes less than 2 hours. So if you do all this, you can use some stack from Uber like Michelangelo, you will be state of the art, really. And obviously I will send a summary of it, but there's a couple of resources that you can use for inspiration, and I highly recommend you to do so. Thank you so much, and I hope it helps you a little bit.